Hey, what is up everybody and welcome back to a brand new video. In today's video I'll be talking about the types of 3D printers, so let's get right into it. So if you would like to see more content about 3D printing, electronics and DIYs, do not forget to smash that subscribe button and enable notifications so you won't miss an upload. Also, you can check my website, first link in the description. It has a lot to offer for 3D printing enthusiasts and articles about electronics and DIYs. And without further ado, let's get right into the video. So at number one on my list we have FDM 3D printers, and this is at number one because it's the most common type of 3D printers out there and it's used by nearly anyone in the 3D printing community. So this is common for a reason, because it's so easy to work with, fix and troubleshoot issues. So it's easy to work with because its idea of operation is so simple and it uses filament, not resin or powder. I'll talk about that more into the video. So basically you have filament fed through this hole on top of the extruder by this stepper motor, as it has a gear on the inside, feeds it right through the hot end, which heats up to averagely about 185 to 235 degrees Celsius, depending on your material. Then after it's melted, it's fed out of the nozzle onto the build platform. So the machine traces the model layer by layer with molten plastic, like drawing it but with molten plastic, so the model is built layer by layer. So some of the common issues with FDM 3D printers are poor first layer adhesions. This is one of the most common issues with such machines, and it makes a lot of people decide not to get into 3D printing because a lot of YouTubers talk about first layer adhesion, and it's one of the most common issues out there with FDM 3D printers. Also, layer separation is one of the biggest issues with FDM 3D printers. Another issue with FDM machines is the nozzles getting clogged. So this is one of the most common issues that we have here in the 3D printing community with FDM machines, and it is the nozzle getting clogged. So if you ship out with filament, some filament manufacturers do not really take their time with filament production, and the filament is contaminated. All those dust particles and stuff like that get stuck down in the nozzle, and it's a very fine nozzle, like it's 0.45 millimeters. The hole is 0.45 millimeters. Not all machines, but basically the average. And it's so fine, any dust particle will clog it and it will make a lot of issues. Also, warping is one of the biggest issues out there, as putting molten heated plastic on a cold build platform will cause warping. That's why we use heated beds most of the time with most materials. So some of the things you need to keep in mind with FDM machines is bed leveling to prevent first layer adhesion issues. It's so obvious actually, but take your time with it, do it the correct way. Also, you need to take care with your infill and your shells and stuff like that. You need to properly tune them in before you start 3D printing. So at number two we have SLA 3D printers, and SLA 3D printers are so much more complicated than FDM, but for a reason, because they deliver a much better quality than FDM machines. So basically, if you hold a 3D print from an SLA machine, you will not notice the layer line, so it looks like casted plastic. And this is such an amazing thing for people who make scale dioramas and stuff like that. SLA machines is the way to go. So the amazing print quality comes from its idea of operation. So basically, SLA machines have a series of mirrors that aims a laser on a tank full of UV sensitive resin, and when this laser touches the resin, it hardens and solidifies and builds the model layer by layer. So it's quite slow, but it delivers good quality, and it's slow because it has a single laser tracing the model layer by layer. So some of the issues with SLA machines is the resin. So the resin itself is toxic, so you need to take care while handling it. You need to wear gloves and safety glasses. Also, the resin not solidifying is one of the issues with SLA machines. Basically, if your resin is quite old, your laser is not tuned in correctly, sometimes the resin will not solidify and you will waste time without even printing something. Also, SLA machines are quite famous for missing details and deformed prints. So sometimes the resin hardens in all of the print, and just some small details, the resin does not harden enough, and sometimes you lose detail. Also, first layer adhesion is an issue just like with FDM's 3D printers. So some of the things you need to keep in mind while working with an SLA machine is being on a level surface. So as you can see, this table kind of wobbles, and this is not good for SLA machines, because if the resin is not level throughout the print, things will not go as planned. Also, you need to pay attention to your resin levels, so there are specified resin levels for each SLA machine out there. Take care and do it correctly. Also, the post-print cleaning. So SLA 3D printers need a lot of post-print cleaning opposite to FDM 3D printers. So basically, FDM, you need to just remove some support material and stuff like that, but SLAs, there's a lot of post-processing after you get the print out of your machine. At number 3, we have DLP 3D printers, and DLP technology is very similar to SLA technology, but it's much faster. So it's basically a better option than SLA. Why, you might ask? Because it uses projectors that flashes an image of a single layer all at once, rather than tracing it with a single laser. So basically it delivers the same great quality of SLA, but in much quicker times. Some of the common issues are actually the same as SLA, but DLP has more issues like brittle prints. So this is a common issue with both DLP and SLA. Also, layer separation, first layer adhesion, and shell quality, just like in SLA machines. And the things you want to keep in mind is exactly the same as SLA. Last but not least is SLS machines, and this technology is quite on the industrial side of things. So basically the machine takes a lot of space, its material takes a lot of space, but the quality is fantastic. And actually this type of technology is not only used with plastic polymers and stuff like that, it's used with aluminum powder and stuff like that, and it prints parts that goes into racing cars and stuff like that. So its idea of operation is so complicated. So first of all, you have a tank full of powder, and you have a roller on top of the tank, and basically this roller spreads powder, roughly 0.1 millimeter thick layer of powder, and a laser, just like in SLA machines, traces as a layer. But before that, the tank that is full of polymer powder has to be heated right below the melting point of that polymer, and the laser, when it touches the polymer powder, it hardens it and it starts to create the model. So basically this technology is for industrial purposes, prototyping, having parts in mass producing parts and stuff like that. So basically it takes a lot of space, the powder tank takes a lot of space and stuff like that. So after print is finished, the powder surrounding the model and the model gets ejected into a container, and then the model is extracted, cleaned, and the rest of the material is recycled. So such machines and such technologies is for industrial purposes, not for house usage. And if you have a workshop, you have the space, you have stuff like that, you can use such machines, but it's so complicated to work with. The idea of the roller and the CO2 laser and stuff like that, it's kind of complicated, not like FDM, DLP, or SLA. So some of the common issues with such machines is the color range. So color range is very limited with such machines. So basically you print and paint, you don't print in colors. Like the common colors, I guess, is white and gray depending on your material type, not the color pigment inside the material with SLA and FDM. Also, a lot of people complain about the surface feeling like sandpaper. So there's basically surface defects, and rough surfaces is a big issue with SLS machines. And the last issue is that it takes a ton of space. So basically you have a huge machine that has a CO2 laser and a big tank full of polymer powder. So basically it's a complicated process, uses a lot of energy and a lot of space. So again, it's not for home usage, it's for industrial usage. So that is pretty much it for this video, guys. Hopefully you enjoyed it and learned something new. If you did, do not forget to subscribe and smash that like button, as it helps me a lot. And with that, the video is over and I am out.